Hey guys, welcome to Code Guides. Today in this session, we'll discuss the implementation part of the vector DB, and in this session, we'll demonstrate how to use the Chroma Faiss, that is the Facebook similarity search library, and we'll see vector how we can store the and retrieve document embeddings from the databases. So first of all, we'll see why should we use the vector databases. Why should we use databases? First of all, to store the high dimensional embedding, to store high dimensional embedding can be from text images. Second is to enable the fast similarity search. Enable fast similarity search. That is the semantic search. And third is the scalable for millions of records. Scalable for millions of records. That is the reason we use the vector databases. Now next is the advantages. We'll discuss the advantages. Why we use them. The speed. First is the speed. So it is fast nearest neighbor search. Second is the flexibility. Flexibility. So it as it supports different similarity metrics, different similarity metric. And third is the integration. That is, it works well with LLM pipeline. Like, right. Okay. Then we'll discuss the disadvantages. Next is disadvantage. That is, it requires embedding model separately. Model separately. Next is it can consume memory with large data. Can consume memory with large data. And third is some databases. Some databases like Pinecone are paid or cloud only. Now we'll discuss the use cases. Use cases. First of all, for semantic search like question and answering, question and answering. Then for code of recommendation. Next is for RAG. Then for document deduplication. Then for vector-based recommender system, vector-based recommender system. So these are the use cases. Now we'll start with the implementation part. First of all, we'll install the necessary packages. Install necessary packages. First of all, we'll install ChromaDB, CPU, and sentence transformer. Second step is to import the library. import library. So we'll import numpy as an NP, which is used for the numerical operation. Then from sentence transformer will import sentence transformer, which is the pre-trained embedding model. Pre-trained embedding model. Then we will import ChromaDB. This is the Chroma vector database. Then from ChromaDB, you will import embedding functions. That is the utilities for Chroma. For Chroma. Then we'll import that, that is the Facebook similarity search library. Facebook similarity search library. And at last we'll import the web. Okay. It will take some time. Now in step 3, we'll create a sample corpus. We'll create a sample corpus. We can document equal to, was the first example is the cat sat on the mat. Okay. Next is those are the next fed. Next would be artificial intelligence is transforming the world. Next is suppose pine trees are evergreen. And last is suppose machine learning model require lots of data. So this is my sample corpus. Now fourth step will load the embedding model. Fourth step is it load the embedding model and we'll load the embedding model and generate embedding. Okay. So I'll mention the model here. Sentence transformer. I'll mention the model name. All meaning LLM or LM. I'll pick V2. So this is basically an compact and efficient model. Compact and efficient in model. I mentioned the embedding with the model dot encode and I'll make a document. Okay. So it will generate vector embedding for each document. It will generate vector embedding for each document. Now we will see for the chroma. First of all, let's see with the chroma example. I will print chroma DT example. First of all, I'll create a chroma client instance. So create a chroma client instance, permission, chroma client, permission, the chroma db dot client. Then we'll create a collection to store our document. So create a collection to, store our document. Permission, chroma selection, chroma client, create collection. Stop. Then we'll add documents to the chroma collection. Add documents to the chroma collection. That will be for loop for I comma doc in number 8. I'll mention the document and say chroma collection dot add document doc. I'll mention the ID of I. Okay. Always remember ID must be a string. Okay. Then we will query our chroma with the semantic question. Query chroma with a semantic question. Mention result equal to chroma collection dot query. I'll mention the query text. I'll mention the question. Suppose what are AI models? AI model. I'll mention the end result. Result equal to 2. Then I will print the chroma result. I'll mention. Good. So it has given result according to the document. First one is the artificial intelligence transforming the model and machine learning models require lots of data. So the question was what are AI models, and it has given answer according to the relevancy. So AI models is more matching to what is the second and the fourth document. So artificial intelligence transforming the world and machine learning models require lots of data. So it is analyzing all the documents and according to that to giving the answer. So this question is related to this document. So that's how ChromaDB works. We have got also the similarity, and the first document is more similar to the query, and the similarity is 1.03. For the second or the fourth document, that is machine learning models require a lot of data. We have the more semantic similarity in the query. That's how Chroma works. Now in next example, we'll see the face. So that is the Facebook similarity search library. So we'll see that face example. The print example. First of all, we'll get the dimensions of the embedding. So get dimension of the embedding. I'll say d equal to embedding, and I'll mention the step. Okay. Then I'll create a flat L2 index and say create a flat L2 index here in the page index, page index flat L2 already. Okay. Now we'll add the document vector to the page index. We'll add the document vector to the phase index. Index. Phase index. Dot add. Then the dot array. And I'll move to the embedding. Yeah. I will encode our query. Answer is the top two similarity document. Link code for query and third the top two similar document. For query, I will say model dot encode, and I'll mention the question here. Suppose I'll say what is machine learning. What is machine learning? And I'll mention the distance, comma, index, distance, comma, index, phase index, dot, first. I'll mention the query, mention the k value that I want for two clauses. So k equal to 2, k equal to 2 means return 2 clauses, and I will print the math document based on index. Okay. Based on index. When if result I for I in index. Index. Okay. Run this. So we got the answer at the two closest documents we got. We have asked the question what is machine learning, and we got the two closest. Now if I mention only one, so we got the relevant answer that the machine learning model is required a lot of data according to the document. So in this way, the phase and the chroma are used to retrieve documents. Similarly, which is similar towards the what we can say the query, and we can use this for vector store. We generally use ChromaDB, and for production purposes we go with Pinecone, but Pinecone is paid and it is cloud based, so that is a disadvantage. But we can use ChromaDB if our tasks are small and also the phase, and we can basically retrieve the document similar to the query based on the semantic similarity. And I hope you guys understood what we did here, how the vector databases work. Right, we loaded the document, we created sample corpus, and we discussed the why we should use the vector database and advantages, disadvantages, use cases. Now you guys can include a different corpus here, sample corpus, and see how it is performing. You can include multiple documents. So here I have included only 5. We can include 15, 20, and ask question and see it is able to retrieve that particular document based on the semantic similarity and see which one is performing better, whether it is the chroma or the phase. Okay, and I'll see you in the next session with the new topic. Till then, take care. Bye.